Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VQ syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 44 for the subject, which is a new module that is called as Pneumatic Control Circuits. And these are the concepts which is as per the syllabus we are going to discuss in detail in the coming slides. Now, first we will understand what is called as simple pneumatic control. Pneumatic control involves controlling of direction and speed, that is nothing but the velocity, of the pneumatic actuators using control valves and pressurized air. Control of actuators are broadly classified into two groups. One is called as a direct control and another one is called as indirect control. In direct control, the valve controlling actuator is directly controlled by actuating the valve. In indirect control, the valve controlling the actuator is controlled by another valve called as pilot valve, and hence such a control valve is called indirect control valve. The valve which is controlled by the pilot valve is called as pilot operated control valve. In some cases, control valve requires large force to actuate the valving element. Application of such large force will be difficult even in manual actuated valves. In such cases, another valve exclusively for actuating the control valve is used. Such a valve is called as pilot operated valve. Now let us discuss about the C. Pilot operated valves at much lower pressure and hence requires less force to actuate. The pressure at which the pilot valve operates is called pilot pressure. The pilot valve directs the pilot pressure on one side of the end land of the main valve, and the force exerted on the land actuates the main valve. The pilot valve is actuated by any methods used for actuating the valve such as manual, mechanical, solenoid, etc. depending on the force required. Thus, the main function of a pilot valve is to amplify the force applied to actuate the main valve. The figure illustrates the construction and the principle of pilot operated valve. Direction of motion of actuators are controlled by directional control valves. Speed of the motion of the actuator is controlled by flow control valves. Now let us understand the concept of speed control of cylinders. The speed of motion of any cylinder can be controlled by throttling the flow of compressed air either at inlet or at outlet or at both. The degree of speed control available from such simple methods is suitable for a wide range of applications, although actual response time will still variable if the load is variable because the varying compressibility of air against different loads. Actual speed control as such, however, of less important rather than reducing the speed of operation to satisfactory level or avoiding excessive operating speed which increases wear on the cylinder and hence the wastage of air due to leakage. Normal speed range is 0.5 to 2.5 meter per second and attempting to operate at lower or higher speed can cause the problems. The different methods commonly employed for controlling the speed of pneumatic cylinders are as follows. Metering inlet, that is nothing but supply air throttling, metering outlet, exhaust air throttling, and modified meter outlet and using a hydraulic cylinder. We will discuss each one of them in detail. What is called as metering inlet? In this case, the variable flow control valve is fixed in between the inlet part of the cylinder and the compressor, which you can observe in this figure. Metering inlet will produce uniform speed if the resisting force is constant. In this case, the first pressure is built up in the cylinder and the piston starts moving only when the force exerted by the air is greater than that of static friction and resistance load. That is nothing but the external load. The piston continues to extend at a more or less uniform speed with the speed governed by air admission. Any increase or decrease of resistive load will decrease or increase the speed respectively. Coming to metering out or metering exhaust circuit. In this case, variable flow control valve is placed at the outlet port of the cylinder, which you can see in the figure. Initially, there will be a rapid or a sudden movement of piston followed by slowing down as air gets compressed on the piston rod side. Coming to modified metering outlet, much better control can be achieved if the metering outlet circuit is modified as per the figure which is shown right now. In this case, the piston is held in the retract position under the pressure, which you can see in the present figure A. When the DC valve is operated as shown in the figure B, the piston will start moving before the air in the rod inside start going through the outlet port. This avoids initial jerk and smooth movement through the extension. Coming to the last type or the concept that is called as using an hydraulic cylinder. The metering in and metering outlet and the modified metering outlet methods of control speed of cylinder will function satisfactorily as long as the load and the line pressure remains constant. More precise speed control can be achieved using a particular for a fluctuation in load or line pressure using a surge damping in the system. This would normally demand for an oversized system with a surge tank in the circuit. For greater accuracy of speed control, a hydraulic check valve may be employed. This consists of a hydraulic cylinder mechanically connected to pneumatic cylinder so that flow in and flow out of hydraulic cylinder is a function of the air cylinder movement. Oil is forced from one side of the hydraulic piston to the other side through an adjustable flow control valve, and the speeds as low as few millimeter a minute can be accurately controlled, and the figure shows the arrangement of such a hydraulic damper. Now I would like to stop the session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.